Hi, Dr. Bennington here with a short 5-minute tutorial on coordinate systems on maps. The most widely known and widely used map coordinate system is longitude and latitude. Most people have some familiarity with this. Longitude lines are lines that circle the Earth from pole to pole. Latitude lines circle the Earth parallel to the equator. Therefore, latitude lines are often referred to as parallels, and longitude lines are called meridians. So the equator is the 0-degree latitude line. We measure latitude counting towards the South Pole in degrees of south latitude, and we measure latitude counting towards the North Pole in degrees of north latitude. The 0-degree longitude line is called the prime meridian, and we count longitude counting up to the east of the prime meridian and counting up to the west of the prime meridian. On the opposite side of the Earth, the prime meridian is referred to as the anti-meridian, or also referred to as the international date line. The equator passes most famously through the country of Ecuador, which was named for the equator. The location of the prime meridian is defined by the location of the Royal Naval Observatory in Greenwich, England, based on the location of a telescope that they use to fix the position of the prime meridian relative to the stars. The UTM coordinate system divides the globe into a series of rectangles defined primarily by longitude lines. Each longitude rectangle is given a number, and then the north-south latitudinal divisions of the grid zones are given letter designations. New York and the Hofstra University campus are located within grid zone 18T. The way the UTM coordinate system works is that any location within a grid zone is defined by the number of meters north of the equator of that location, and then the number of meters within the grid in an east-west orientation. And the east-west location is defined relative to the middle of the grid zone. So in UTM, we have a northing coordinate and an easting coordinate. So the numbers get larger as you cross a grid zone from west towards the east. And that's different from longitude. Longitude numbers increase from east to west. So now let's take a look at the topographic map that you're working with in the lab, and just make sure that we can locate and that we understand the two coordinate systems as they're shown on the map. This particular map is a detail from a map of Herrick's Corner in Pennsylvania. And if we just kind of zoom in on the upper left corner of the map here, you can see there's a bunch of numbers printed along the edge of the map. If you go to the corner of any corner of a topographic map, you should see the longitude and latitude coordinates labeled. So here we see two numbers which are recognizable as longitude and latitude because they are designated as degrees and minutes. Remember, longitude and latitude are essentially angle measurements that are measured in degrees, minutes, and seconds. So we have 75 degrees, 30 minutes. That's the longitude value. That number is associated with the longitude line that runs down the western edge of the map. And then we see 41 degrees, 45 minutes. That's the latitude value. That's associated with the line that runs across the top of the map. And then a little bit over from those two numbers, we see this number 459,000 meters east. That's a UTM coordinate. So that number is indicating a location to the east of the edge of this particular grid, the grid zone that the map is in. If you look over, and that number is associated with a grid line that runs down the map. If you look over to the next grid line, you see another number, 460. So when UTM coordinates are noted on these maps, except for the upper left and lower right of the map, they leave off the last 3 zeros. So you would read this number as 460,000, the next coordinate as 461,000. So with UTM, you're not measuring in degrees, minutes, or seconds. You are measuring in thousands of meters. So it is 1,000 meters from this line to the next line. If you want to interpolate in between the grid, you just have to estimate how many hundreds of meters are you between the lines. If you're halfway, that's 500. So the halfway mark here would be 459, 500 meters east. If you're 3/4 of the way, that's 750 meters. If you're 9/10 of the way, that's 900 meters. Right? So it's very easy using UTM to interpolate between the marked grid to come up with a fairly accurate designation for a particular location. If we continue along the top of the map, we see another number here, which is marked in minutes and seconds. So that is a longitude number, right? You will see the longitude number is associated with lines that kind of run north-south. They run down the map. Those are longitude lines. Notice that the degrees are missing. On topographic maps, they tend to leave off the degrees except at the corner of the map. So really, this number is 75 degrees, 27 minutes, 30 seconds longitude, and you really should say west longitude because in the United States, we're west of the prime meridian. If we go down the map on the other side, we see a number here, 4,620,000. That is the northern UTM coordinate. So that means that this line here is 4,620,000 meters north of the equator. That's the 0 line for northern coordinates in UTM. 1,000 meters south of that line, we have 4,619,000, 4,618,000. So again, UTM lines are counting by thousands, and it's fairly easy to estimate in between. Halfway in between would be 4,619,500. And then finally, in the lower part of the left-hand side of this map detail, we see another longitude-latitude coordinate in this case, because this number is associated with a line that's running east-west here. We know that this is a latitude line. Right? So the latitude coordinates will be marked along the edges of the map, and the longitude coordinates will be marked along the top and the bottom of the map. Again, the degrees are missing. We have to go look up at the corner here, and we see, that's 41 degrees. So this number is actually 41 degrees, 42 minutes, 30 seconds north latitude. Okay, I hope you found that quick lesson on latitude, longitude, and UTM useful and helpful for completing the lab. Thank you.